y equals x.
Yeah, reflection across the y equals x. Maybe that's yours. So it's a reflection across the y equals x. So you can think of an inverse as you have a function, right, or a graph, and then when you just switch all the x and y coordinates, it then, that's its inverse. And so it does reflect, as Nate said, across the y equals x. So then when we have a function like this, let's say, so this is 10.4, let's say we have a function, f of x is equal to 2 to the x, we also call it y equals 2 to the x. What kind of graph, well not, well it does form a graph, what kind of function is that? Is it linear, right? Let's think through the things we know. There's linear functions, there's quadratic functions we've learned, there is radical functions we've learned, and then there's the last one, which this one would be. What would this one be? Exponential, yeah, because where's the variable? In the exponent, okay? So the general idea is that you have an inverse function, a function of a exponential function, okay? And if you were to graph this, we know that it goes through at 1, and it goes something like this, okay? So that's the graph. If we were to graph its inverse, okay, the inverse would be reflected, as Nate said, across the y equals x line, and wherever you have a over 0 up 1, then becomes over 1 up 0, and if you had negative 3 1/8 is what it would be, negative 3 1/8, then you would have 1/8 negative 3, and your graph is going to look like this, okay? So that would be its inverse. This would be, and you remember the notation, f inverse of x, okay? It's not f to the negative 1, that's just a notational thing, f inverse of x, okay? The general idea of this, though, is going to go to this. The inverse of an exponential function is going to be what we call a logarithm. So when you hear the word logarithm, like mathematically, like most of your parents probably don't remember this, or they probably learned it at some level if they went through high school math, but they probably don't remember it, or if they did, they're like, oh, logarithms, they suppressed it. But the general idea is that it's just a notational thing that represents inverses of exponential functions. So when you see a logarithm, it's going to look completely different because it's going to be a whole new notation thing. All it is a way to represent some sort of exponential function or expression. So when you hear logarithm, think exponents, okay? So with that, exponential function, you have its inverse, okay? A logarithm, again, the general idea, just think exponents, exponential functions. A logarithm is going to be written like this. It is going to be log, and then you're going to have a base, b, of, let me use the same letters they use. Log base b of n is equal to k. Okay, log base b of n equals k. Again, this is a whole new notation, but you can take logarithmic notation and take it in and out of logarithmic notation and actually just put it in exponential notation. So it's essentially an exponent, but but a different notation for it. It's kind of like, in some ways, not the same, but if you had 10 over 2, you could also write that as 5, just two different ways to write it. Now that's easy because you learned that in elementary school, right? Here, you're going to look at this like completely different. However, it's just two different ways to write exponential functions, and so I'll show you what that means. Okay, so a logarithm, general idea is this. Logarithms have a base, okay, and then it's of a value and it's equal to a value. Okay, now let's give, the exponential form of this would be this. B to the k is equal to n. So if you got rid of the word log and said, I want to take a logarithmic expression, and I'm going to turn that into an exponential expression, the exponential expression is base b to the k. A lot of people want to say b to the n, which would be natural, because it even looks like b to the n, but it's base b to the k gives you that value n. We'll do some numerical examples and then see what it see how it works. Again, the confusion a lot of times is that it's just got this weird notation log, L-O-G, right? And it's like, what does this mean? But once you get hopefully used to going, oh, exponential form, then it should make sense. Now, b cannot be 0. Okay, there's some restrictions. B can't be 0, and or B can't be 1, and it has to be positive. Okay, so here B can't be equal to 1, and it has to be positive. So we don't have negative bases there, which we don't see a whole lot of anyways. Okay, so let's do a numerical example of this. If I give you log base 3 of 9, so we wouldn't say log 3, because if you said log 3, you don't need to write this, but if you said log 3, you're really saying that. You need to identify that the base is 3. So you're saying log base 3 of 9. Now what that is asking is, you are asking 3 to what power gives you 9? And so log base 3 of 9, we would say is equal to, okay? So again, you're saying 3 to the what? This part is your exponent, this part is your base, and then this is the value that it equals. So 3 to the what gives you 9. So log base 3 of 9 is equal to 2. Now, in exponential form, that would simply be 3 squared equals 9. Okay? I guess we could call that number 1, just working on what that would be. So if we go number 2 here, let's try another one. Log base 5 of 125. So if we said log base 5 of 125, again, we're giving you ones that we should be able to do mental math on. Meaning 5 to what power gives you 125. So a lot of times what you'll see is your answer is just going to be 5 to the what. They don't show it in the logarithm form. The answer would just be 3, like that. And where did we get to 3? Well, we're asking 5 to the what power gives you 125. One way you can do this, if you're like, I'm kind of struggling with how to mentally think through log base 5 of 125, you could set this up and say log base 5 of 125 is equal to what? So you pick a variable like x. Then you could write it as 5 to the x is equal to 125. And now, remember, powers are the same base. We've done that numerous times. And then we say, okay, 125 is 5 to the third, therefore x equals 3. And so that would be the same thing if we can't mentally work through it. Okay. So let's do another one, and I'll have you do this and see. Let me do this. I'll say log base, whatever, 4 of 17. If I gave you log base 4 of 17, does that one, based off your limited knowledge of logarithms, and number 1 that we did, number 2 that we did, now we're looking at number 3, does that one look, oh yeah, I can follow that and get the answer? Maybe you can't get the answer just because it's like, you don't understand at all what's going on. But if we follow the pattern, right, we're saying, what is the base for the exponential function that we're dealing with? The base of 4. So we're saying 4 to the what power gives you 17. Is that like an easy one to think through? 4 to the x is equal to 17. No. Now with a calculator, with some work, we can get there. No problem. But is that a mental math one? No, you could guess, I don't know, 4.1 or whatever, but that's not a mental math one. Or maybe I'm going to start like 4.21 or something. But it's not a mental math one. So at this point, you would need a calculator, which we're not going to do right now. That's not what we're testing. So let's do another one. Log base 4 of 16, okay? Go ahead and do that one. Check with your support team around you. And then we'll do log base 4 of, mix it up a little bit. Still do log base 4, but then we'll do a 1/4. Mix it up a little bit. See if you can mentally work through that one. Check with your support team again around you. See what they might have. And then we will do this one. Now some of these mental math might be a little bit challenging on it. Other ones, so you might need to set up some sort of equation, kind of like I did on number 2. If the mental math part is a little confusing, you might want to set up a little equation like we did on number 2. Just a pro tip, no problem that people are grabbing calculators out, but none of these require any calculator work. It's okay if you're trying to do something with calculator, it's not wrong, but none of them are, at least to my knowledge. I may have put one up there that's a little challenging, I don't know, but most of them, I think they all should just be able to do like mental math with it. Should, but we'll double check as we go through it. So double check, we have 4, 5, 6, and 7. See if you can get those 4s, hopefully pretty straightforward based off what we're learning. And then 5, 6, and 7. 6 and 7, you might want to follow what we did on number 2, setting up an equation. And we'll throw this one up there. Number 8 is a little bit different, but we want to solve for x on number 8. Using the same pattern, we'll see if we can extrapolate this out. And then same with number 9. So see if you can follow the same pattern, same work on these. Then we check with your support team, see if you guys are doing the same thing. If not, try to work through it. We'll go over these in about 1 minute. If you don't have it, no problem.
What did you do?
If you want to check with an adjoining table, that's fine too. If your table is struggling, you might want to check with another table. See if you can work through it ahead of time. Maybe have them all, which is great. Here we will be calling upon tables to see what you got. So fear and trepidation.
Can we use number 4? Can we call number 4?
Yeah, we did? Okay. Holiday is called number 4. Very good. You want number 5.
We'll do number 5.
Alright, Amanda wants number 5. Who wants number 6?
We'll do 6.
Chipper takes number 6.
We'll do 7. We'll do 7. We'll do 7. Yeah.
Jackson, 8. I don't know if there's another J. I don't know.
I know.
What is this?
That was Bergen. Oh, wait.
7. What? Okay, and then Haley, good job. You guys taking number 9. What? Okay. So here we go. Holiday. Number 2, or number what? Number 4. Hey, number 2, Holiday. What'd you get? What'd you get on number 2? 3. Good job. Okay. Number 4, what'd you get? 2, because we are asking 4 to the what gives you 16, right? So 4 squared gives you 16. That would be your answer. Okay, Lander.
-1.
-1, you bet. You can double check, right? You're saying 4 to the -1, whoops, is equal to 1/4. Is that true? Sure. 1/4 is equal to 1/4. Good job. So the answer, again, if you wrote equals -1 or something, that's fine. You can say it equals -1, or you just write like the number 2 and the -1. Okay, Chipper.
16.
16. What Chipper said is a base of 1/2 to the, this is where maybe you want to set up a little equation. They don't give it to you, but you say 1/2 to the x is equal to 8, right? So, now we say powers of the same base. What's the base going to be? 2, right? So 2 cubed, 2 to the -1x. Therefore, x is equal to what? -3. So Chipper said 16.
Yes.
I'm glad you went for it. Now, where did you get 16 from? Just saying like 8 times 2?
Yeah.
Yeah, 8 times 2 is 16. Do we see what we did here though? We said, what is this whole thing equal to? So we put x, this represents the exponent. So 1/2 to the x is equal to 8. 8 turns into 2 to the third. 1/2, you flip it, that gives us the negative. So then it's 2 to the -1x, which would just be -x. And then we set our exponents equal, so x is -3. Okay?
Wow.
Wow! Okay, Bergen.
We got 1/6.
1/6, let's check it out. 27 to the what is equal to √3. Powers of the same base, what's the base going to be? 3 to the 3x, right? Because 27 is 3 cubed. And then 3 square rooted, we turn that into what? 3 to the 1/2. So 3x equals 1/2. X is equal to 1/6. Okay. All right, Jackson.
25.
25. Easy W there. 5 to the what equals whatever this is. So when you do logarithms, a lot of it initially here is just following a pattern. Now, ones like this, right, require your knowledge of powers of the same base, which we've been doing since chapter 3. So that's old news once you get to here. Setting it up, hopefully, is just the same pattern over and over and over. Okay, Haley, what do you guys say here?
3.
3? So you're saying a base of 1/9 to the -1/2 is equal to x. Negative simply flips it, right? So it's actually 9 to the 1/2. That's all the negative does. And then what's 9 to the 1/2 the same thing as? Square root of 9. So what does x equal? 3. There you go. Okay. So fairly straightforward on those ones, hopefully. And then let's just do like one more. If you have log base, actually I think 2 more. Log base 11 of 1. This is a classic. Log base 11 of 1. Holiday's got it? You got it?
Yeah.
Oh, nice. What'd you say, Holiday?
X equals 0.
X equals 0, yeah. Now there is no x, but obviously what Holiday's stating is, no, that's fine. You're stating this to the x, so you're asking 11 to the x is equal to 1. Anything to the what power? 0 power is equal to 1. So x equals 1, or you can just write 1. With that, again, the base, if this was a base of 20, a base of 14, a base of 1.5, it doesn't matter. If this is 1, you know it's to the 0 power. People get tripped up on that a lot. Okay. Let's do one more, and let's say you have log base 3 of x equals 0. Log base 3 of x is equal to 0. A furrowed brow in the front tells us everything. What does it tell us?
X is 1.
X is 1. However, actually, that's fine. X is 1. It actually wasn't the problem I wanted to do. But that's okay, that was exactly right. So X is 1, not difficult. Let's do one more. Sorry, it said that was the last one, but that actually wasn't the one I wanted, because 3 to the 0 power is 1. So we got that. Number 12 here, log base, let's do one like this. Log base x, so we don't know the base, of 3 is equal to 0. That's actually what I was originally thinking, but log base x of 3. And then with that, let's go log base x. We haven't done many with the base as x. Then we'll do 13. Those are the last. Those really will be the last two. Again, just set up like the equation and then work through it. So if we look at number 12 together, we'll put anybody on the spot here. What do we say? X to the 0 is equal to 3. Well, what's anything to the 0 power? 1. 1 equals 3. True or false? False. So therefore what? No solution. Here, we just go base x to the first power is equal to 6. Therefore, what does x equal? 6. So if this was 2, right, it would be x squared equals 6, and then you just say x squared is equal to 6, and you solve for x, taking the square root of both sides. Don't forget, though, the base always has to be positive with logarithms, okay? Positive with logarithms. All right, that concludes that. So I think that covers everything. That does. Which should be set. So utilize your time. Tomorrow 10:3 is due, right? 10:4 we can delay another day. That'll be due Thursday.
If the